Welcome to VVIT YouTube channel. My name is Prof.Baktha Singh. So I am working as a professor in the Department of Electrical and Electronics Engineering in VVIT College. So today I want to discuss that is network theory subject. And this network theory subject is for both EC people as well as electrical, that is EEE people. And this subject is very important in the GATE examination. Why it is important in the sense, if we see the scenario of the GATE from 2008 to 2020, so how many marks came from the network theory subject alone in the sense? From 2008, for EEE students, they got 20 marks, this is very maximum score, and at that time, the cutoff mark is also nearly 20. That means, even if you have a good knowledge in the network theory, then it is sufficient to qualify in the GATE examination. And if you see the scenario, so to ECE and EEE, so both are some equal grading. That is, some cases 15 marks is there, 14 marks is there, and 13 marks is there, 16 marks is there for ECE, as well as 17, 10, 12, 20 for EEE. So therefore, this subject is very important in the GATE examination. If we have the good knowledge in the network theory, then we can get and we can qualify the GATE examination very easily. And you see the contents in the GATE for network theory. The first one is introduction to network theory, and second one is what are the various elements present in the network theory. And we know that we have the elements like voltage source, current source, resistor, inductor, and capacitor. And network reduction techniques. So we have some networks they will give, and we need to reduce the network into the single equivalent resistor or single inductance or single capacitance like that. And for that we need to use star delta transformation or delta to star transformation. And moreover, so even by using the series and parallel combinations also, we can reduce the network. And for that, some techniques are there. So in this class, in this video lectures, we used to give that techniques to you. So even by seeing the problem, we can able to give the answer, how the answer will be like that. And KVL and KCL, this is very crucial point for the network theory. So how to apply the KVL and how to apply the KCL, and for which circuit we can apply the KVL, and for which circuit we can apply the KCL. This is very important. And for KVL and KCL also some shortcuts are there. So if you see the problem, immediately within 1 minute, that is less than 1 minute or maximum 2 minutes of time, we can able to solve any network. So such kind of shortcuts we used to teach in VVIT YouTube channel regarding to the KVL and KCL. And next AC fundamentals is there. And if we have the quantities like AC quantity and DC quantity, and moreover periodic quantities, then how we can find the RMS value, average value, and form factor, peak factor, all those things. And what is the J operator? What is the importance of J operator? Next, impedance, reactance, admittance, so power and reactive power, active power, apparent power. So all this comes under the AC fundamentals. Next, analysis of AC circuits. Then how we apply the KVL and how we apply the KCL for the AC circuit. So that will come under this analysis of AC circuits. Next, resonance. This is also one very important topic in the AC analysis. That is, what is resonance? So how we can apply the resonance? What are the various conditions present in the resonance? All this concept, that is voltage magnification factor and the current magnification factor. How we can find all these things in the case of resonance? We will see that also. And network theorem. Actually, so usually, we used to see the network theorems immediately after the DC analysis. But what is the intensity to see the network analysis along with the AC analysis? In the network with the AC also some theorems are dependent. The best example, maximum power transfer theorem is there. That maximum power transfer theorem we can apply for the DC as one type, and we can apply it for the AC in one category. So therefore some discrimination is there from AC to DC in the case of network theory. So in this VVIT YouTube channel, we used to give the network theorems for both AC and DC analysis. Next, two-port network parameters. This is also some important. Next, transients. And next, previous gate quotient analysis. And once again I am telling you that, so in the gate point of view for both EC and EE students, this network theory is like the heart of the subject, like a hard subject for the gate examination. And if you have some good basics and if you have some good knowledge in this network theory, then you will qualify in the gate examination very easily. So now let us start the gate. Now let us start the network theory. So first, introduction. Let us see the introduction. Yes, introduction. So network, in the sense, we have so many types of networks. Computer network is there, communication network is there, and friendship network is there. Like that, we have so many types of networks. But here, this network theory belongs to electrical. So that means electrical network. In electrical network, what is electrical network? And before going to the network, what do you mean by electricity? Yes, what is electricity? Generally, we used to define the cities like Hyderabad, Chennai, Delhi, like that. So, how you define the Hyderabad in the sense it is a city, so which is having the Charminar, like that we can describe Hyderabad. Similarly, what is electricity in the sense? It is also one region. What happened in that region in the sense, one charged body is there, that charged body is excited, and excited charged body used to produce some response. So, electricity in the sense, the region, so where the charged body is excited and hence produce the response. Whatever the excitation which is given to the charged body, that is called electric potential or voltage, and the response of the charged body is called electric current. So once again I am repeating, the excitation which is given to the charged body is called voltage, and response of the charged body is called current. So now let us just see what is electric potential, or what do you mean by voltage. So now let us define electric potential or voltage. So how we define this? For example, this is one electric field. Let us assume this is one electric field, and I have the charge which is located at infinite distance. I have the charge which is located at infinite distance. Now my objective is I want to move this charge to the electric field. Then it requires some energy. That energy is called electric potential. Hence, how we define electric potential in the sense, the energy required to move the charge from infinite distance to electric field is called electric potential. The energy required to move the charge from infinite distance to electric field is called electric potential. Or you can also define the electric potential as the capacity of charged body to do some work in electric field is called electric potential. Or you can also define electric potential as the work done by unit positive charge is called electric potential. Or you can also define electric potential as the V is equal to energy per charge or work done per charge. Now we know the units of energy. The units of energy is joules and the units of charge is coulombs. So the units of volt is volt. So hence you can say 1 volt is equal to 1 joule per coulomb. 1 volt is equal to 1 joule per coulomb. This is regarding to the electric potential. Next, what do you mean by electric current? Yes, what is electric current? Yes, electric current. Yes, electric current. What do you mean by electric current in the sense? The flow of free electrons is called current, or the rate of change of charge is called current, or the flow of charge is also called current. So hence mathematically, electric current is denoted by I is equal to rate of change of charge, that is dq by dt. I is equal to dq by dt. This is the equation, the basic expression for the current. Now from this equation, let us analyze this equation. How we analyze this equation in the sense, for example, in any cycle. For example, in any cycle, the charge changed suddenly. The charge value changed from one value to another value without changing time. That means the change in charge So let it be from 0 to q. So therefore dq is equal to some q value. But suddenly in the sense there is no change in time. dt is equal to 0. Then what is current? Here I is equal to some q divided by 0, which is given by infinity. That is, infinite current is nothing but maximum value. Infinite current is maximum value. So in which cycle the current is maximum, or in which cycle the current is infinity? The cycle, so where the terminals are short cycle. The cycle where the terminals are short cycle. Hence, what do you mean by short cycle in the sense? The cycle in which the charge changes suddenly is called the act as short cycle. The cycle in which the charge changes suddenly act as short cycle. In such short cycle, the current is maximum, hence resistance is 0, and hence voltage across those two terminals is 0. This is the characteristics of the short cycle. And short cycle characteristics are current is infinity or maximum, resistance is 0, and voltage is 0. So these are the characteristics of the short cycle. Now let us consider in one more case. What is that in the sense? The charge remains stationary, but the time is changing. So that means case 2. The charge remains stationary. The change in charge is 0, but the time is changing. So let us assume dt is equal to some 0 to t. That means let it be t lines. Then what is current? Here I is equal to 0 by t, which is 0. So 0 amps indicates the two terminals are open cycle. Hence the cycle is open cycle when the charge remains stationary. The cycle is open cycle when the charge is stationary. In such open cycle, what is the characteristic in the sense? I is equal to 0, but V is equal to maximum, and R is also maximum or infinity. R is equal, that is resistance of these two terminals is maximum or infinity. This is regarding to open cycle and short cycle. These are the characteristics of the open cycle, and these are the characteristics of the short cycle. In short cycle, current is maximum, resistance 0, voltage 0. In open cycle, the current is 0, voltage is maximum, resistance is maximum. And one more case is there. That is, when charge is changing as well as time is also changing. Suppose for example, the third case is the charge is changing. So that is dq is equal to q. As well as current time is also changing. T is dt is equal to t. Then what is I? I is equal to q by t. Now what are the units of q? We know that units of q is coulombs. The units of time is seconds. And the units of current is ampere. Hence 1 amp is equal to 1 coulomb per second. 1 amp is equal to 1 coulomb per second. Already we know 1 volt is equal to 1 joule per coulomb. 1 volt is equal to 1 joule per coulomb. So from these two, so we can obtain some expression. So how it is in the sense? Just for example. Yes, for example, if I multiply these two, that is volt into ampere. We know that volt into ampere is equal to watt. Now what is this watt? Is equal to, we can substitute these values. 1 coulomb per second into 1 joule per coulomb. So that means coulomb get cancelled. Then watt is equal, 1 watt is equal to 1 joule per second. This already we know that. Next, if suppose when I divide this two, that is volt per amp. Volt per amp we know ohms. Now what is ohm? 1 ohm is equal to Yes, volt in the sense 1 joule per coulomb divided by 1 coulomb per second. So that means 1 joule second divided by coulomb square. That is 1 ohm is equal to 1 joule second by coulomb square. This is somewhat important because in some examinations, some common examinations, so like JDO or BSL, JDO that is BSNL or AB Genco, AB Transco. So in such PSUs they used to ask such questions. So the unit of ohms is equal to dash, like that they used to ask. So then we should know about this relation. Or they may ask 1 joule second per coulomb square is equal to dash. 1 ohm or 1 watt or 1 mho or 1 ampere, like that. We should know about all these things. Next, one more aspect is there. What is that in a sense? Ampere per volt. So ampere per volt is mho. Ampere per volt is mho. So then what is mho? Mho is equal to, we know ampere as 1 coulomb per second divided by volt as 1 joule per coulomb. So then we can write this as coulomb square per joule second. Coulomb square per joule second. This is regarding to the mho. And we have one more equation. What is that in a sense? So I hope all of you taken these values. One more equation. What is that in a sense? For inductance and capacitor. That is the time constant is there. Time constant for RL circuit is tau is equal to L by R. Tau is equal to L by R. Where the units of time constant is second and the units of inductance is henries. Units of resistance is ohms. So then 1 henry is equal to 1 second ohms. 1 second ohm. Now what is ohm? Ohm is equal to 1 joule second per coulomb square into second. So hence 1 henry is equal to 1 joule second square per coulomb square. This is important. 1 joule second square per coulomb square is equal to 1 henry. And similarly, the other one for RC network. The time constant for RC network is tau is equal to RC. Tau is equal to RC. So where C is equal to tau by R. The units of C is farads, the units of tau is seconds, and the units of R is ohms. That is, F 1 farad is equal to 1 second into mho. So here we know that 1 second, mho in the sense coulomb square by joule second. Second. So that means second get cancelled. Now what is 1 farad? 1 farad is equal to 1 coulomb square per joule square. This is about the farad. So like this. So we have the 5 units from basic of the voltage and the current. So that is the units for the resistance, units for the admittance or conductance, units for the inductance, units for the capacitance, like this. This is about introduction of the network theory. Next, let us see what are the various types of elements we have. The types of elements in the network. And we know various types of elements such as voltage source, current source, resistors, inductors, capacitor. So these five types of elements we have. And again, these 5 types are the major components in the network. But how we take these 5 elements in the sense? The first classification of the network elements are And before going to the network elements, what do you mean by network? The network in the sense interconnection of the several components together to perform specific tasks is called network. Then what is circuit? The circuit in the sense, if the network contains at least one closed path, then it is called a circuit. So we have one general statement is there. What is general statement in the sense? Every circuit may be the network, but every network may not be the circuit. Every circuit may be the network, but every network may not be the circuit. So in such a network, so the first classification of various types of elements is active and passive elements. Active and passive elements. So active elements in the sense, so in a network, so energy sources are called active elements. What are the energy sources we have in the network? We have two energy sources are there. So those are either voltage source or current source. Voltage source is the source of energy in the form of electric potential or voltage, and current source is the source of energy in the form of electric current or current. So that means the voltage source is represented by in this fashion V, and current source is like this. Current source is represented in this fashion. If suppose the voltage source terminals are minus and positive, so the voltage across voltage of the voltage source is let it be V. When current passes through the voltage source in this fashion, then we consider this voltage source is delivering the power. That means here we used to say power delivered by voltage source is equal to V into I. V into I. If suppose the voltage source is like this value is let it be V, and the current flows into the voltage source. Current flows into the voltage source. Then we used to say the voltage source absorbing power, that is power absorbed, is equal to V into I. V into I. So power absorbed is V into I. But what is power delivered? Power delivered is equal to minus Vi. Power delivered is minus Vi, but power absorbed is Vi. And here if I want to calculate power absorbed, then what is power absorbed in the sense? This will be minus Vi. If the voltage source is delivering the power, then the power absorbed by the voltage source is negative. If the voltage source is absorbing the power, then power delivered by the voltage source is negative. It should be noted. Next, current source. If I take